Hello, fellow Mythrunians. Welcome to another weekly live stream. Tonight we're going to be playing with the physics playground and trying to get characters moving around with forces and stuff, and I'll explain hopefully a little bit why I do that. There are a couple different ways that you can move a character, and I choose to do it a certain way. We can talk a little bit about that. And so we will go ahead and get started. Those are my super cool patrons, although I haven't checked the page recently to see if that list is still up to date. If your name is on there and you're no longer a member, well, you're lucky. You got another shot at it. And if your name isn't, I'll make sure to double highlight it next time. So up in the upper left, hey Max, how's it going? Up in the upper left is the link where you can get the last release, which was from like last week, last Wednesday or something, which has all the cool hand drawn stuff and spirit portals and cool things like that. So yeah, not a whole lot other than working on this physics playground. Let me bring up my little... Gotta crack the Pepsi open. We'll get started. So I did play a little bit with looking at so somebody posted pictures in the Discord of hold on a second, like of some hand-drawn stuff they took, and I thought it'd be cool to have little signatures in the corner. Yeah, that's an example. And so I had played with various fonts to use, and I think ultimately I'm going to come up with some set of fonts that the player can pick as their handwriting, so when there's anything handwritten in the game, it'll use their handwriting. But I thought it was kind of cool. Some cool little fonts for handwritten stuff. So I did spend a night playing with that because I needed a break. But mostly I've been playing with this physics playground stuff. And I ported everything we did last week over to the open source version, which of course doesn't have access to all the fancy blocks. But I can use it in the other one, and it will. And there's still a couple bugs in here, but right when this started, I was trying to debug why the rig seems to be offset from the view. So I need to deal with that, but yeah, I'm still not quite sure, so I'm doing some debugging. So we get this, when we click over to Physics Playground, we get this little thing where we can set up, what we want the world to be made of and what structure we want and so on and so forth. And then we can say Start Simulation. And then it'll start the simulation up. And I've currently got the debug physics on because I'm trying to figure out why the model for her seems to be above the actual physics shape. So I was adding this physics debug, and I'm not sure which is wrong at this point. So that's what we're going to do initially. And then hopefully we'll play with, moving her around. There's another thing is like, she goes to sleep and wakes up again. The physics puts her to sleep and wakes up again, and every time she does, she jerks. And so that's a sign also that the physics debug is not quite right. What that's a sign of, first of all, she shouldn't be going to sleep. That's easy to fix. But what it's a sign of is that, so JMonkey Engine, when you move from one pose to another, by default it will sort of quote unquote tween between those two poses to make it smoother. And I think what happens is that every time she gets reset like that, it resets her pose to some weird shape and then turns her back to this default pose, which is actually supposed to be the idle pose, so there's a problem there too. And so then she crumples like a ball for a second and then straightens up. And I think that then does weird things to her. But like, yeah, the way this is set up, let me type correctly. Let me make sure I got all of this. But once I get it stabilized to the point where we want to be running live scripts and updates and things, we can use the regular Mythruna graphics. And hold on, I'll show you in a second. Although I have it hard-coded to be Mythruna girl at the moment, I do plan to fix that. So if we go over here and we run the Mythruna specific flavor of this particular tool, excuse me, we will, so we have access to our own thing, so we can set the grass to be the top and dirt to be the inside, and we have our own playground over here. And if we start this simulation, she comes in, and then we've got Mythruna graphics. But it's hard-coded to her rig right now, so I can't use any of the other rigs. What I want is another set of things here where I can pick which rigs we use, or probably that's going to be the scripted piece anyway. But see, this one has the same problem, even though it's technically a different rig, because anyway. So that's what we're debugging right now, is trying to figure that out. But before we go into that, let me talk a little bit about why I do what I do this way. Let me see. Where is my whiteboard? I have too many. It's this one that I force crashed at some point. Well, we have 6 concurrent viewers. If you are new to the channel, welcome. So let's let Miro boot up for a second. There's a couple different ways to move a character in a game, and I think a large portion of games use, if they have physics at all, they'll use what's called a kinematic rigid body. So as the if you imagine it from a top down, where you've got it hiccuped right there. So you've got various objects in the world that are hanging out, and this is your player, and there are their eyes, and they're looking this way. Maybe this is their hair, right? Arms. And so they're moving in this direction. They have a presence in the world, meaning that when they bump into these boxes, they'll move the boxes aside, but they are otherwise kind of, they are not controlled by forces. They are just at the location they're at, and when we move them a little forward, they are at that location, and they moved, and they'll bump things out of the way. But if this box tried to move them, they wouldn't move, because they're fixed in space. And so any reaction you want from the world, you have to program in to know, oh, that box hit the player, I need to move them back. That is a pretty typical way, because it's really easy. It's like the player has a jetpack on, and you push them forward, and they'll go forward regardless of what's in their way. They'll just push it right out of their way. The rig visuals affecting position at all. So hold on a second. So what Mythruna does, and generally this is the way I approach physics. Hey Ron, how's it going? Generally how I approach physics is that the player, or any mob for that matter, is just another physics object like any other. If you bump them, they'll move. If the wind, if there were wind, if the wind blowed, they'd move. But that means that when we decide that they should walk forward, we have to apply a force to their center of gravity, and we have to pick a force that's going to work to overcome the friction of the ground. If you imagine from the side, when we have a player that's sitting here and they want to go up this ramp, we're going to give them sort of a force in this direction, but we're going to have to overcome, if they wanted to go up this ramp, we're going to have to overcome the ramp. And so you have to sort of combine what this character's intent is. They want to move forward, or they want to move up the ramp, with their current state. Are they even on the ground? Because if they're not on the ground, technically they can't walk at all, and they have no, unless you give them like 3D platformer kind of, where they can kind of control. And then Mythruna works this way right now, right? If you're in the air, you can still control the direction you're falling, even though that's not realistic at all. But it feels good. And so, in Mythruna right now, and in a lot of games, when you're in the air, you don't have as much control as if you're on the ground. So you have to keep track of whether they're on the ground, whether they're on a ramp, translate forward the idea that they want to move forward into the right forces to get them to overcome whatever friction they're standing on, while recognizing that they're going to get pushed by stuff, or that the thing they're standing on might be moving. Because that's the other thing, is if this is a moving platform and they want to go forward, it's not their world position that's changing, it's their position relative to what they're standing on. So you have to take all this into consideration: what they're standing on, whether it's moving, what the angle is, and then hey, how's it going, Galactic Taco? That's a cool name. And what their intent is, and combine all those into a force value that makes them look like they're doing what they're doing. As to Max's question, why is the rig visuals affecting position at all? So when you have a physical animated object, let's run the regular rigger, and I'll pull up Mythruna Girl for a second. So when you have an animated object, they have, their physical shape. So this is Mythruna Girl, and she's got her shape. I've given her a simplified collision shape, so this is how she interacts with the world. If we turn her walk pose on, you can see she's got feet that can kick stuff, and this is sort of her collision with the world. So that's where she's sitting on the ground, that collision shape right there. She has kind of a body just so that when she interacts with doors and fences and things, that she'll get blocked, and she has a head because if something hit her in the head, you'd want to have her move accordingly. So the rig is animated on the server, this sort of low resolution rig. And then in the client space, you've got the nicer visuals that are the actual model, but the bone and skeleton, the whole armature, is kind of shared by both and then synced up. In a network game, the same thing that's sending her position to the client is also sending the sort of the animation and what time in that animation we're playing, so that the rig can be synced up with the movement. And so on the server side, you sort of have you have the rig, which is just the bones, and you have these simplified collision shapes so that it can interact with the physics world. And then on the client, you have, the JMonkey engine spatial model with skin, and that follows the rig as well. But what's happening in the playground, and I can't actually, there's a bug right now. If I flip over here, it doesn't get rid of this. So I'll have to exit out for a second. And so there's a problem right now, and I can't explain it because I don't know what's wrong yet. So hold on a second. So there's a problem right now where the physics rig, you can see it is interacting with the world correctly, and that her world collision is sitting where it's supposed to. But for whatever reason, the quote-unquote client-side visuals, which are the JMonkey engine spatial, yes, well, that's the trick, right? Standing on the slope without sliding. So my contention would be that where I want to go is easier when the player is not fixed in space. So, like, if I threw a ball at her right now, she would get moved back because the ball hit her. I don't have to code that, it just happens. If she's standing on something that suddenly starts moving, again, she just starts moving, I don't have to worry about it. I believe that the code to, especially if I get to procedural animation at some point, I believe that the code to decide what her animation should be based on what she's standing on and how she's moving. I believe that that code is very similar to the code that I will need to decide what forces to apply to keep her standing on a slope and so on, right? And we actually don't want her to stand still on certain slopes. If the slope is pretty steep and she's standing on it, she should slide down. So that is already happening appropriately. It's these slopes where she should be able to decide on that I need programmatic control over. And my contention would be that the code to decide how to do that is very similar to the code to decide which animation to pick, for whatever she's doing, walking upstairs, walking up a hill, climbing over onto a 1 meter cube and so on. I just got this working, and I'm just not sure why the spatial doesn't match the. And so I'm thinking of fixing animations where every time she falls asleep, bad things happen. So I got to fix that right away. But anyway, that's my contention, and so far I've done pretty well with it. Mythruna already works that way, and mostly other than the fact that, again, they slide down the slopes and they can't walk up the slopes. That's the problem we're trying to solve here. But that's why this physics playground is kind of cool. I keep looking down at Max like he's sitting down there in the chat. He's right here. But his text message is down there in the chat. But that's exactly the point, right? But I mean, you basically touched on the crux of the dilemma, right? Which is why I've created this physics playground. Because ultimately, when I go to choose animations and stuff, it's going to be nice to have this little smaller application that runs quicker, that I can just try things. Because at some point, if I can't get procedural animation working down the road, I'm going to have to build, a state machine that takes the inputs of the desired movement with the the terrain that they're standing on and the contacts they have, not context, but contacts that they have with the physics space and so on, and turn that into animation based on the tree, the state machine that they can go through. And I believe that those state transitions will also inform how I apply forces. That is my contention, that we will prove, that I will prove eventually, or fall back to standard programming practices. It's just, I get a lot for free out of this approach, so I'm hoping I can make it work. And so far, that's been the sort of focus of my development anyway. Doing things that seem like they're harder, but they come with a lot of benefits, and so if you can make them work, so be it. What was I doing? I was going to look at rigid body so that I could figure out what I need to do to... Yeah, military doesn't care for this such things. Already Mythruna works pretty well. The player can walk up and down ramps. The player goes slow up ramps. The problem is the player has the person behind the keyboard knowing that they can walk up that hill if they were to push hard enough. And also right now the physics driver that drives the player avatar is different than the one that's driving the mob characters. And I want to make them the same. And so that's the other point of this, is to combine a lot of that code, because every time I fixed something in the player, I didn't always go back and apply it to the mobs. And the mobs have different, excuse me, I have an itch. The mobs have different requirements anyway, so some of it doesn't transfer, but I'm hoping that with this little physics playground and being able to have a mode where we can jump into the NPC and run them around with the keyboard, so that I can play with player type controls as well, that I get to someplace. I think that I can just say wake up. Yeah. Wake up. Yeah, let's always wake up fully. So yeah, wake up. Okay, so I have this character driver, which I'm kind of... Yeah, that's where I'm headed. but but even still, if you take, yes, so the intended direction that the player wants to go, going back to this picture, so right, the intended direction. So when the mob wants to move this way, if he's standing on a hill, he really wants to move this way, right? So I need to apply the forces within his strength to do so, the stronger forces necessary to, because how it works right now is I calculate the desired velocity and I apply forces up to the maximum amount of force that can be applied to reach that velocity. If I reach that velocity, I back it off. So there's like this constant push-pull to get the player or the mob up to speed. So they try to maintain a certain velocity relative to their ground point. And so yes, step one would be, instead of doing it only in the horizontal plane, to allow that to have some verticality, but not in such a way that they, fly. So you have to be like really in sync with what's on the ground underneath their feet. And you have to consider that if we really were running up a steep hill, we would be slower, and so on. So like you said, right, you have to kind of take all that into consideration. I appreciate that there is someone on the stream that actually understands this topic. I have that feeling that makes it a little clearer for everyone else. So thanks for asking these questions. So back to this, we want to go back over to here, and we want to say, I just keep waking up the body. Body, wake up. Yeah, so this is kill any. Yeah, so this is what keeps the player upright instead of falling on the ground. If I took this out, they'd flop all over the ground. So already I'm breaking the rules here by doing this so that they stand upright. So my contention is what I just did should get rid of the jerky stuff, and they should just be constantly kind of, well, there's a color coding that's in the debug state. Yeah, so when things turn blue and go dark blue, that means they're falling asleep. The fact that this one's kind of like a constant, you have trouble seeing it over this yellow, but this ball that's representing her physics shape, her whole physics shape, right? It's not doing a very good job of calculating. I wonder, yeah, her center of gravity is in a weird place too. I may need to play with a different character. Could be that her model's just messed up. Anyway, you see how it's kind of like a yellowish red color over this. That means it's got a high temperature. The physics engine uses a form of sort of simulated annealing to decide when it can stop paying attention to certain things. So this guy got real cold. That's why he's blue. When a physics object doesn't move, their temperature goes down. And as their temperature goes down, they apply more accurate physics. And in a sense, right, because it's using basically it multiplies their temperature by the time step, so they get slightly more accurate math, but they slow down a little bit. But that's to help resolve some of the, when you have like objects stacked on each other and stuff, it kind of helps resolve so that they eventually fall asleep. But we're constantly waking her up, so she'll never go to sleep. That's why hers is kind of that yellowish red color, and constantly flashing between that and like a blue, because it's trying to cool down, but we're constantly waking it up. But that keeps her animation going too. So what do I want to do? I think I want to let's make sure it's not just her rig that's broken. So I'm going to temporarily hard code. What is the... We've got... Where do I put the rigs over here? Oh, it's in... let's see, I put them in resources. So they're both source main resources, rigs, human, female. Let's do human female dot rig, which is going to break on this side, but we'll get it to run on the other. So again, I've hard coded this. I really need to make it a configurable parameter or something. So human female dash or slash human female. I know that's redundant, but there's a directory taxonomy here going on. So if we Gradle install this, I think it's funny. Last week I posted, 3 different Twitter tweets and Blue Sky skeets or whatever they're called, and we only had like 2 or 3 people show up, and this time I only put out 1 all the way around, and we've got 7. That's cool. Maybe the topic is more interesting. I'm certainly better prepared, other than this bug that I spent the last 2 hours trying to figure out. It's going to be funny if it turns out to just be the rig that's bad. Actually, I don't want to do that. I want to go here and say start simulation is going to... Did I get the... No, I did not. Human female rig. Cannot find source main rigger dot resources rigs human female. Oh, female. Oh, I did spell it wrong. Hopefully one of you was yelling, "You've spelled it wrong." I played some more of that Astronauts game last weekend, and I got a lot farther. I was able to actually earn some money. Yes, I do eventually want procedural animation. I just think in the long run it's going to fit the goals of the game better, especially when I get to the point where I want to have VR controls and things. Trying to coordinate where the player's hands are with where they should be standing based on what they're standing on and stuff, I think will be easier with... I mean, even though that's harder all over, I think it's easier with procedural animation. I did it and then I didn't install it, so I got sidetracked. Oh, I did, didn't I? Human, but it didn't take it. So I must not have. Oh. Uh-oh. So, yes, eventually I would like procedural animation. In the meantime, I'm doing what gets me by, which is pre-canned animations. And I'm going to stick with pre-canned animations for a long time because they're way easier to deal with. I just load into... I got good at making them in Blender, and certainly for creatures and stuff. But when I get to the point where I'm making larger creatures that have to interact with the land, big rideable creatures and stuff, it's going to be really important that their feet don't fly around in the air. Why? Models human. Okay, so that's on the client side. I apologize. Asset not found. Source main resources, models. Human. Oh. 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 So that's interesting. That's unfortunate, really. So I'll have to fix that. So yeah, this is wrong. I hadn't gotten a chance to go through the past to make these 2 things compatible, which is why we're kind of kludging it. And I just, again, if this one turns out to be off too, then we're right back to where we started, and I've still got to debug it, and I'll use Mythruna Girl to debug it. But I sort of, and actually, Mythruna Girl works okay in the... Okay, hold on. I think this is going to be incorrect too, but a difference... Whoa. We've got... A shader problem. Somebody has changed and not been installed. Line 647. Or I've got an override somewhere, maybe. Yeah, what the hell is that? Oh, it doesn't have local lighting, so it's basically a path that the regular game never tests. Excuse me. I can talk sometimes. So, thanks for chilling with me along on these. Wait, this was local lighting, so I'm in the wrong place anyway. This is going to be here, I think. Source main resources, no. Blocks. I could just search, but what fun is that? Oh yeah, I actually had this open. Mat defs. Local lighting. That is .frag. And so if we want to look for has local lighting. Blink. So this needs to be vec4. At least I don't have to install anything. So anyway, as I was saying, I played Astronauts, and I'm watching the guy. I'm still watching the stream that originally got me turned on to Astronauts. And I'm talking about my typo before. I'm yelling at the screen, you know, when he does something wrong, you know, that I notice, like the rest of his audience. They, you know, he's doing it a live stream in a chat. I'm watching it on recording, so I can't tell him. Like, you forgot to do the thing. Don't forget to put your helmet on. 653 B local lighting, local light dir. Yeah, that's true. So let me actually. Sorry, I'm having to like hack together compatibility stuff into my shader here. So if ndef, do we actually use this? Ooh, no, we were smart there. Okay, so maybe I just need to be smart about local dir as well. Local dir is used right there. So I could actually vec3 local light dir equals vec3 0. Pointing up is better than nothing. And I get rid of this. Alright, let's hope that's the only problem left. I just don't really want to... These characters are set up to run in Mythruna. This is the material that they're set up to use in Mythruna, and when you're in Mythruna you have local lighting values which are based on, you know, the in-world calculated lighting, not the sunlight. See if we get a shader error again. No, we didn't. Alright, she have the same problem? Yes, she does have the same problem. And her texture's all wigged out because she's got the default pre-painted one, which has I flipped the UV maps around at some point for the arms and the face, the face and hands and stuff got moved around. So anyway, that's going to be fun. So yeah, it's got the same problem. So that means we can debug it over there. It's that's interesting. It's like the center of gravity is not correct. I think I do remember that with these models. The center of gravity is at their feet. Okay, she just fell into a hole. The center of gravity is at their feet, which is fine. But it's not actually. It's the center of the bottom part. There's a offset that has to be applied. I think we grab it from so yeah, even though this is called human remail, so what was I thinking? I want to see what she has defined as center of mass. No, center of mass is up here. Okay, so that's not it. Let me see what the regular model stuff does. So this is the Mythruna model loader. And if I'm going to spend another 5 minutes on this, but we can do everything else we want to do without dealing with this problem. Yeah. Get center offset. So, but no, this is for something else. Yeah, so that's we use that for determining what their light value should be in the world, so that center of mass value. But that's not actually setting the offset for the spatial. But I do sort of remember that there is an offset applied for rigs. Not here. Not here. Let's look at... I thought I already had this open. Mob container. Oh, you know what? I know what it is. The shape on the server knows what that offset should be, and in Mythruna, the server side applies that offset before it sends the value over the network. Where can I find that? That is... Is that on the server code? So... so many pieces of code. Somewhere in here is a thing that takes the position of... I bet we're using... It takes the position of the physics object and turns it into a position of Sim Ethereal, which is the open source network sync library. It puts it as a position on there. And when it does that, it translates the value based on that offset, and that's why I'm not used to having to do this. I just want to spend a couple minutes finding this, and then we will proceed. Trying to remember who does that. It's going to be related to sim ethereal, which is set up in the zone network system, which I thought was set up over here. Is that a standard part? The problem with having broken up Mythruna into an open source layer and a non-open source layer is that sometimes it can take a minute to track down what we are looking for. So that's why I was starting with the server, because the game server code sets up everything that happens. And so somewhere on here it's setting up the networking, and the problem is, like, while I'm on a live stream, I have trouble stopping and actually reading stuff. Somewhere we've got ethereal host. Here it is. We've got a time source, but somewhere we tell that where objects are. Yeah, with the network state listener. Okay, so that's not helpful. Okay, so what do? We add the service, a zone networking system. This. Where does it come from? No. Is it in... I'm going to guess it's in the body position stuff. It's probably in several places here. No, mphys. Okay, so this is part of the physics engine. It makes sense. For the M block shapes. Yeah, sure. Right, because anytime you have physics, there's a good chance that you're going to want to network it. And so SiO2 mphys, yep. And then should be here under .net, yep. Okay, zone network system, physics observer. Yeah, so here, so we have the physics body, which is unfortunately something we don't have on the client. Oh, but but we do where I set, so anyway, okay. I know what to do. We go to, so I broke out everything into, in the playground stuff, I broke out everything into kind of a mini game that's controlled by this playground menu state. So this is where you set up all your UI stuff, and then eventually you click go, start the simulation, and it adds this playground physics state with all the things it needs in it. And so this is like a little mini game that sets up the physics, sets up the model viewer, the world viewer, sets up the world. And so playground physics playground state has a bunch of app states underneath it. Now, I use state not in the conventional sense. Unfortunately, JMonkey Engine used the word state to be a pluggable sort of application service, if you want to call it that. So you can have a bunch of different states in your application. There are ways of extending application without actually extending it in the object-oriented sense. So you have all these things that are resident that control. They basically intercept behavior and do stuff. So they have a life cycle, initialize, cleanup. And so physics playground state is the one that it basically instantiates all the parts of the game. So it's like a little mini game. So it's like a little mini game. Playground physics playground state is like a little mini game. It has a game system state which runs all of the background simulations that if you had a client server system, this would be what was running on the server. It has a worldview state which says, hey, give them the world that's on the server, render all the things. That's what renders the ground and the little playground. And then it's got a model view state which says, for any of these entities that have shapes and physical properties, I want to render them in the world. But in this game system state, we kind of fake the networking layer by having this guy down here. No, where did it go? Or did I do it over here? I know I added this. I probably just did it in line. So here where we set up physics. Yep, add physics listener right here. So we have the body, and we have the position we really want, and then we can steal this little magic bit of code to use instead of what I'm passing. So basically, I was taking the body position directly, and instead we want to we want to take the body's shape and say, what would your world space origin be? Because the client side, the viewer, that's where it's going to be locating it. So your physics body has a center of mass that's based on the physics body, and you want all your forces to be applied to that center of mass. And so as far as the physics engine is concerned, that is where the object is, and it will apply all forces to there or relative to, I don't know if you guys can see, I can't even, I don't know if I'm in frame when I'm doing all this stuff. So you've got the body, center of mass, and all the forces will be applied relative to that center of mass. So if you apply a force up here, it's going to move it and rotate it around that center of mass and so on. But the model itself has its own origin, which is usually at the feet. And so on the server side, we want to think of the object at its center of mass. But on the view side, where we actually render the model, we want to think of it as its feet. And so what happens here is that's what we're asking. We're saying, where is the shape origin for this particular body? So for that body shape, give me the shape origin for that body. So that would be the model position. And so then when this is unfortunate because spawn position is also used for something else. So I think we're going to have to make a new component, unfortunately. What I can do is reuse. See, in the client server environment, there's body position, which is not here, here. So if you think about, there's two timelines. If you've got the client up here, I should really just learn to use the text tool. Okay, so you've got a client timeline, right? Tick, tick, tick. Clicking along at 60 frames a second or whatever. And then somewhere you've got a server. I'm not going to write the whole thing out. And it's got its timeline where it's doing its game ticks, however many times a second. And then you've got the network that's transferring them over every so often. And there's going to be a delay, right? The client is going to see things a little bit later. And you may, in this case, we're going to send, several frames at a time. We already know the client's going to get late. The client is actually looking a little bit back in time, so to speak, because it's getting these values late. So anyway, when we have this thing called there's this component called body position, which the server writes to, or the server updates it and the client gets it and it writes to this body position. And body position, I'm just going to abbreviate it as BP, has a list of values. It goes back like 6 values, or so it goes back like a second, if you want to think about it. There's some period of time it's capturing, so that when the network data comes in, We add it to the front, but the client's actually viewing a little bit back in time. And because it might be viewing not at an exact time, we interpolate between whatever these two good values that we know from the server are. So that's why you get nice smooth animation on the client. And the lower your latency is, the closer to the current value it is, but you're never right at the current value. You're always just a little behind, or behind 1 frame or 2 frames of this data. And so even though we are not in client server and we are doing everything instant and locked into frame, I can still use this component because and just basically give it a history of 1. But that'll be distinct from spawn position. The problem with reusing spawn position is that the physics engine knows where to place things based on their spawn position. So when you change the spawn position, the physics engine is going to try to move it. And since we're about to tell it that it's in the wrong place, that would be a problem. And so I think I don't even need to be smart about this. We're not using body position like normal. Normally you'd set the body position once and then you would just keep updating it. Unlike normal components, body position manages its own threading. Normally, yeah, so I've already got this open. So body position. I just want to see what its methods are. I think I can just get away with constantly recreating it and adding a frame. Always saying visible. Just going to steal this stuff and constant silica BPOS. So in the entity component system, let me just paste this down here for a second. So in the entity component system, normally, one thread could be looking at its own view of the entity, with a certain number of components in it, and another thread can be looking at its own view of that same entity with its components, because each of them says at a certain time, okay, I'm ready to see the latest values in this object. So they'll get a new position and they'll get a new name or whatever, new shape, whatever. This guy can do the same, and they've got their own views, and so they don't collide, and there's never any contention, and so on and so forth. The entity system handles all that for them. But usually in the case of body position, you set it once, and then all the threads that are using it just become readers on that one. It never gets reset. It's a strange component in that it handles its own threading. So that's what I mean when I say that. Surely you can get the collider's bottom bounds that should be the model's position. Yes. That's what I'm doing, but only the server knows that. The client doesn't know that. So the client code only knows the spatial. It doesn't know the rigid body. It doesn't know where the rigid body is. I guess it does. You may be right on that. If I reuse this, I can use this. No, so it's more complicated than that because the orientation of the rigid body and stuff matters. So basically I would have to write a new method like this that would take the components of the body. And right now it already diverges quite a bit from normal game code. So by using body position as a separate position, I'm making it more like all of the other game code and more like what it would look like in a networked environment. So I think this is better. And so we do body position, and we don't need any history. I think we have to give it at least 1. And actually by using body position, I don't know, I'm getting ahead of myself because at some point we're gonna have to deal with animation, but not tonight. Man, I said I was only going to spend 5 more minutes on this, and I'm not. But I thought like we were kind of getting an education as well. So I'm just gonna try. Actually, it doesn't really matter. I can do 10. So I'm just gonna do 4, 3. Doesn't matter because we're always going to be And I don't need the entity ID because we're not sharing buffers. So bpos, add frame. Oh, we are going to need the time though. No, we're not. We can just use system nano time. It literally doesn't matter because we're not going to be tweening or anything. Just has to move forward. So then we do body, model position, and then body orientation. And yes, it's visible. And we set that component instead of spawn position. Actually, we'll set them both because it's useful to have spawn position be up to date. Okay, so let's just make sure that compiles real quick before I go on and fix the client. Alright, so on the model view state, instead of being based on spawn position, we're going to be based on body position. And we're going to need to pull in bpos. Body position, bpos is part of the open source stuff, if anybody cared. The open source, not yet published open source stuff. Okay, and so then in here, instead of spawn position, I get body position. And I think I can say get last location, get last orientation. Let's see if it compiles. Yeah, so let's see if that fixes the problem. Boo 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 boo. Uh-oh. Oh, right. I didn't put, did I? Yeah, I didn't even save it, right. Oh, I did. Okay, so I gotta put back to use this Mythruna girl. I was still using the other rig from real Mythruna. Not the one with the grid close. Okay, back to this, and let's pick a better starting color. This is something I could do in a script. So start simulation, we'll get at least green grass or something. Yeah, okay. Okay, is she? Yes! Yay! She's sitting on the ground. Okay, well now I know why. And eventually when I do animation, I'm going to have to tap into a similar thing. So yeah, okay, so now we can deal with the stuff we actually set out to deal with originally. Great success, yes. We're an hour in and we can get to the topic of the actual video. Yes, do you like my test texture on the blocks here? Yeah, so the open source Moss stuff, it's built in block set shapes and stuff are based on this palette texture. So this green here is actually this green right here. But I made one shape that's got all of, or one that's got all of the shape types and uses just the the palette texture as the texture. And so that's why when I translated over from the Mythruna Stone version to this one, it was the only one of my block type sets that had the right shapes in it, all the different ramps and things. Okay, so we can actually do stuff with her now, which is we've got an hour to mess with. And so we can talk about what's next. First of all, I'm going to put her in a different place, but we're going to figure out what we want to do with scripts. So sample 2, we'll just stay over here for now. Do I have the scripts set up here? Yes, init scripts. Scripter init scripts, yep. So we can put scripts there and do things. And we're going to be messing with this character driver. That's what makes the motion happen eventually. It can collect the physics contact, so it knows when she's standing on something and what it is. And that's the way the current one works. I have been sitting in front of a computer too long today, and actually that really hurt. Okay, so we're going to want pluggable pieces in here, but before I do that, I want to script some of the so playground menu state. I want to have some initializers here. I also want to know why this isn't working. Because we're supposed to, anyway, that's not, we don't need to worry about that. So what do I want? I want to run some scripts when we initialize this. But I need to be able to set them during startup. Script state is initialized last? Yes. So I can init scripts, set up train .groovy, oops, and what is the script state? What is it giving? App. So we should be able to say app, state manager, get state, import com, so silica tool, right? Tool, singular. It's a toolbox, not a tools box. Star. Get state. Playground. Menu state. And then it should already be initialized. So we ought to be able to set some things. Set top type, set ground type. I just don't want to. I don't want to have that yellow in the background, but I don't want to hard code anything either. I know it's kind of dumb, but int index equals block type index dot find. It will save me a bit of clicking to do. Oops. Find type block name. Oh wait, that's not here. Find type name for type entry in cube types if entry index equals index, then we will top type set selected item. I think it's item. Set the selector set selected item. Yes, I was correct. Entry. Return. And similarly, we will say ground type. Okay, so then we ought to be able to just test this. This will also verify that I haven't broken scripting, so it's not entirely a waste of time. Alright, so we go over here. We ought to be able to say set top type new block name. Oh, we're going to need to import that. New block name. What's it? We want base 7. Actually, we want base 31 cube. Let's see if that. Yep, look, did it. Whee! So we need to do the same thing for ground type. It's the little things. No. Set ground type. Did I name it something else? Set ground type. Alright. Misspellings. That's going to be the death of me. Okay. So next thing we'll work on is wiring in. I just want to make sure this works. And that'll tell us whether we can wire in like a custom driver factory. Okay, so if we go this, yep, it's already set up. And so if we start the simulation, the colors will be set right from the beginning. Green background. That's actually a brown color. You can't tell, but it is brown. It's just got full light on it at the moment. The lighting in here is really harsh. And when I turned it down, the lighting and the characters look dumb. So this is where we are. Okay, so she's doing her thing. I want to also make this toggleable because that's going to get annoying seeing that all the time. So we will real quickly also put the eye-piercing yellow. Yeah, I mean, it was definitely bright. Okay, so we want, I think it's lemur props. I'm going to assume for a second that it's, oh, yes, that's interesting. So we want to public boolean is physics debug enabled. Return so first of all, physics, ooh. This is interesting because we're several. It doesn't exist when we want to use it. Physics debug enabled. Set physics debug enabled. Boolean debug physics. If debug physics equals, if this debug physics equals debug physics, return. Otherwise, this dot debug physics equals debug physics. Oops. And playground. So I think I import PG star. Yeah, okay. So or yeah. So this is the thing that's going to be painful for every one of these that we want to do. But if if playground is not equal to null, playground set physics debug enabled debug physics. And then when we start it up, we're going to have to do the same thing. And then over here, I'm going to have a and then we say if get state not equal to null, get state set enabled. Okay, I know this is sorry about this, guys. It's just gonna drive me crazy. Okay, so sim buttons. We're gonna do another thing. Window property debug settings equals window add child new property panel. Debug settings add boolean property, and I don't remember exactly what the where do I have the nearest example of here, right here, right next to it, in fact. So add boolean property physics or body debug this. I'm going to steal the name so I don't get it wrong. Physics debug enabled. Okay, so we should be able to toggle that on and off now. It should be off by default. Big sort. Yes. I knew that was going to happen. I predicted it. Remember? And it takes a value I forgot. It has not been updated to the new way, and by new way I mean the way that's been the way for the last 6 years. Property panel is one of the earliest Lemur add-on utilities I created, and it hasn't kept up to date with some of the newer conventions, like not having to specify a style. So you pass null as the style and it will use the default style, but there should be a no arg constructor. So yes, we can start the simulation. Base app state. Set physics debug enabled. Line 90. If because we are not initialized yet, Toggle simulation. Alright, I'm gonna be expedient as soon as I can remember how to spell in Q. Alright. It's gonna do it the next frame. Okay. This only took us 16 minutes. Okay, so we should be able to start the simulation. But, oh, because it doesn't have an application yet either. Alright, that's going to be a problem. Except for what we really need to do is do it over here is what the problem is. So we will enable that later. Oops. Alright, try again. We just keep trying. That's all you can do is just keep trying. I'm sure there's a ancient Chinese proverb that's appropriate for something like that. Anyway. Okay, yay, no physics debug, but if we turn on physics debug, we get physics debug. Ah, woo! Look at that. They all randomly came in here for once. It's nice. It's trapped in the little, in the thing. Okay. So yes, now we have reloadable scripts. Now I need to think about what I want her configuration point to look like, and in a way that we can reset it. So, what do I want to say? I think we will be okay, so let's stop and think for a second. We want to be able to use a script to add new behaviors that will affect all characters. But we want to be able to reset it at runtime. So I think something static would work. Sort of a way to delegate these calls to something static. That then we can swap out. So I'm going to make a scriptable driver. Ooh. If we do that, so in Groovy, if we instantiate a real class, we won't have the same cool scoping to our global bindings that we would if we had set a bunch of closures. So I think instead I'm going to do separate closures. Oh, you know what though? We can work around that. So scriptable driver, that's fine. It's going to be an interface. That's not going to matter because it's still going to do it wrong, but it's the template for you. So we don't need this, we don't need this. But we do need to take all of these, all these methods and put them over here. But we're going to add, so the initialize we want, that's the same. Terminate, yes, that's, we get to take the whole body, that's fine. New contact, we're going to need to give it the body so that it can do something with it. Actually, we're going to want state. the thing. So we're going to want to collect contacts. We're going to want to know, rather than have to consult like a hash map or something to look up our state all the time, maybe we want to be smarter about this. So the issue is we want this to be able to call. Yeah, I mean, there's no way around it. So we want to have kind of a public static scriptable driver delegate, right? So this can be set by the script. And so then in each of these cases, if delegate is not equal to null, we will set delegate. Of course, initialize doesn't make any sense. Terminate doesn't make any sense, because this is going to be like a global life cycle. We're going to change it while there's drivers already running. But still on the update loop, we'll be fine for that. So new contact and update is all we really want. And those will both want state. But it's not state we can. Okay, so we body and contact is fine. Actually, we can get the the body is in the contact technically. But yeah, and we're gonna want, why don't we just pass the character driver? It has everything on it we want. Yeah. I like that. And technically we could have character driver create. Does it take anything? Nope. So then we could have custom character drivers if we wanted to. But the default, so default, oops. Yeah, it's never going to come up because we're going to already have them created anyway. Blah 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 blah. I get it mixed up about life cycle sometimes. Okay, so in new contact we want to call this one. Yep. If delegate is not equal to null. Delegate new contact. This comma contact. And then after that, we can say if delegate is not equal to null, call this, else do that. So we will let delegate.update this frame time step. And so basically, we will only do the default anim pump stuff if we'll always wake up. But that will let the delegate deal with the animation. And it should have access to all this because Groovy gives us access to the private things. And so we should be good. I don't know why the action isn't set correctly. Maybe Mythruna Girl does not have an idle. No, I'm sure she does. Anyway, we can mess with that. Alright. So we ought to be able to run, assuming that I bother to import the right things. Oh, we're going to need mblock. Oh, this is not in the right. Yeah, never mind. It's this over here. And it's going to need mblock shape, which is here. Entity ID. For some reason, this is not finding delegate, but I think maybe I spelled it wrong. Delegate, yep. It's the delegate. Not the delegate, but the delegate. Okay. So we should be able to start the simulation, have her sit there doing her thing, then in a set up terrain. So we'll do it in here, even though so import, it should be in a separate script. Tool PG character. We'll just do star. Oops. And so we will say update body equals. Let me copy this interface to save myself some trouble. Actually, we'll do setup driver.groovy. Hey, how's it going? Dependency, I think this is how I say it. Setup driver groovy. Oops. And I just want to make sure this doesn't blow up. Oh, I got rid of the supposed to recopy. Oh, that's up here. Okay, so let's see if this likes it. Nope. Add dependency. It's scripts. No. Rigor script state scripts. Add script. Of course. There we go. Okay, so now we've got that as its own script. I don't have to worry about it. I have a pun for you. It's a really sharp knife pun. Uh-oh. What's the difference between comment haters and knives? I don't know. What's the difference between comment haters and knives? As we all wait with bated anticipation, one is sharp, the other is dull. Okay. If you say so. It's funny. As a dad, I'm all about the puns. I know I've hit a good one when even my kids repeat them later. So contact. Oh, no, this is the update one. So we want driver, long frame time, double step, boink, boink, boink. And we want new body, contact, driver, contact, and then we will say character driver, character driver delegate equals new scriptable driver Your puns aren't that good. Does anybody know where a king keeps his armies? Oh, you know what? This is not going to work like this. We're going to have an actual class. Ouch, yeah. Two men walk into a bar, which the first one should have noticed. The second one should have noticed when the first one said ouch, yeah. In his sleeveys, yes! What's brown and sticky? Chat police doesn't allow ASCII. Oh no. Now the brown and sticky, a stick. What could be more sticky than a stick? Is anybody doing anything productive, creative these days? More sticks. Or a tree, yeah. I just like that a stick is sticky. Because it's a stick. It is sticky. It is like... It is a stick. It is sticky. It's so bad. I've been making more code. Yeah, is it is it useful code? That's the question. I'm trying to implement Surface. Oh, neat. Surface Net's mesh generation. So, in what sense? Like surface nets from what? You have piqued my interest. Oh, like ISO surfaces, that kind of thing? Like metaballs? Marching cubes? Oh, new contact. See, I spend so much time hitboxes to where the player hitboxes doesn't just fall through the world. Yes, always important to not fall through the world. A bit smoother. Okay. Creating a SharePoint online modern internet at work about. Wow, pretty cool. Okay, so something it doesn't like. Oh, I've got this dangling guy out there. Still doesn't like it. Oh. Well, for one thing, I don't need all that, but I'm gonna want all the things. Still in block shape. I'm gonna steal that from yes, from here. Oh, setup driver. Oh, it ran it. Yay! Everybody's working on cool stuff. That's nice. Sometimes when I ask that question, you guys are, I don't know. So that's awesome. Everyone should try to do something creative. It helps the soul. Body. Contact. Update body. So, if I do this, I ought to be say log info update, and we should see that start streaming. Yeah, check it out. Okay, so if I take that out and refresh, it goes away. Okay, so we've got Mythruna girl sitting there on the ground. Whoops. I ought to be able to give her a force. I got to remember how to do that. 2 men walk into a bar. One of them bets the bartender he can pee in a cup across the counter. Bartender for $5. Yeah, pees all over the counter and gets $500. I know so many of these guys walk into a bar jokes. Some of them are even less appropriate for mixed company. And that joke can actually go on quite a while because you can have the guy come in. Like, guy walks into a bar. He bets the bartender that he can bite his own eye. And the bartender says, nobody can bite their own eye. Puts his $100 down. And so the guy, pulls out his wooden eye, bites it, and sticks it back in his eye. And then let's try to move our campus utility data to an interactive out. Wow. Yes, I bet they do. So anyway, you can string a lot of these bets along until you get to the last one. And I've heard the joke told as like the guy going, he's getting audited, and he brings his lawyer and they pee all over. Anyway, there's various ways that that's a good joke. Update body. What do I want to do? Rigid body. Rigid body. I may have to play some astronauts this weekend again. It's such a huge time suck, but man, it's like a second job in space. Alright, so we want to say, I want to set the linear acceleration just to see if I can. And that way we'll get like the principle of what we're doing here. But I shouldn't have so many files open because then it'd be easier to switch back and forth. So set up driver. So let's just say driver.body set. Let's just see if she will move if I give her a. I think she looks down the z-axis. Will this work? No, because I don't have that imported. Yeah, look at, she's moving, but not in the right direction. It's in world space. Let's move her back a little bit. Oh yeah, she's got so now I need to set it to 0 is what happens. There's nothing resetting it, so there you go. She's got friction working against her. She's actually, why didn't she fall into the hole? That's another problem. Okay, so she is slowing down. So she has essentially no friction right now, so she easily slides around. But we are controlling her through physics, and we need to. There's a whole bunch of stuff that's got to happen, right? But we've got the basics of what we're trying to do here. So let me think. We need to, first of all, let's picks blah 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 blah. Driver body orientation mult new vec 3d 001. Okay, so this, if I send her in this direction, it should move her forward. So let's get her so she's in view. Except for it's not. What if can I apply a torque? So this is not really applying a force per se. It's setting raw acceleration, which may actually be better for what I want to do. But we may want to add a force instead, because then it resets itself. So let's do that instead. Where am I? Set up driver. So instead of that, let's set it back to 0. Okay, so she'll stop trying to walk into the wall eventually. I'm going to keep that in my back pocket. And so we wanted to set or add force dir. Alright, let's make it -1 per second. Yeah, so she's slowly moving back because the force will just keep accumulating. And if we stop adding it, she should stop eventually here. Right, she is slowing down, believe it or not. I have to see what default physics, not physics, friction I'm using in the regular characters. When we get a driver, what do we do with the driver? Set linear dampening almost at max. I think we need some amount of damping, or we will have tiny math errors. Yes. Okay, so that's different. The big values are better. She's still ever so slightly sliding away. There may be a default friction that's applied, but let's set damping. Where am I? Oh my god, my brain is going, gone. Got too many things open. Set up driver, not groovy. You know what I'm going to do? I'm going to make a new file and put stuff in it so it's red. There we go. So we shouldn't be setting this every time, but I don't have an opportunity to set it any other time. So let's try this again. Okay, so now she's moving forward. I should turn it off. She should stop faster this time. No. Something in Mythruna sets the friction of the contact. I'm looking in the wrong place. It's in new contact, which unhelpfully is here. Okay. Can fully reach our target box with just regular calculated acceleration. However, if we ever really do want mobs to move different rates over different... Yeah. I don't think friction is 0 normally. She walked all the way into that wall. Let us log what the contact friction is. Friction, not frication, friction. Okay, so she's got 0.7. That's high. That's normal high friction. is she moving forever in one direction? I know it's I think it's related to the desired force, right? We set her in motion. There's nothing stopping it again, and that's another. That's the other aspect of this picture that I'm talking about. So you have to take the character intent. It wants to move forward. Therefore, we apply a force until it gets up to the velocity that it intends to go. But then when it stops moving, if it's standing on the ground, it applies a force to stop. Like, if we keep walking, if our legs suddenly didn't touch the ground and we could float, we just keep moving in that direction. We apply a force to the ground to stop moving, even if it's that fact that we're not walking anymore. So there is a sort of mechanical friction, if you will, that comes into play, and that's what we don't have with her. At any rate, so first of all, let's give her a... Oops, that's not what I want to do. Let's turn that off for one thing. So friction's good. I don't think we need to mess with friction. I do want to give her a slight rotation, though. How best to do that? I think the Quaternion class has a rotate on it. I don't think we need to do anything with the rigid body. I think we can we just rotate local? Or maybe we have to set... I don't know. I just want to get her wandering around in a way that she'll stop when she's done moving, and I'm starting to have to go to the bathroom here. Okay. Okay, so what we'll do is we will give her an actual direction, which means we're going to have to keep track of the things. Body state. We want a double yaw for now. We're going to need more things, but we will have a body index. And so, if body state, body index driver, if state equals null, state equals new body state, body index, put driver, state. So this is the kind of thing that we end up having. Cube collider for legs. Imagine the character is on a unicycle. It's a cube instead of a wheel. No sliding, only static friction. Jumping didn't work well on slopes, though. Yeah, again, everything has a trade-off. Isn't it frustrating? Why can't it just work? Okay, so now we should have a state that we can use, and if I wanted to, I could state yaw plus equals step if state.yaw is greater than math.pi times 2, then state.yaw minus equals math.pi times 2. So now it'll roll around in a circle, and then we can say driver.body.orientation from angle 0 state.yaw 0. And so, yep, now she'll turn around. And we can slow it down. That's too slow. Let's go like there. Okay. And so now if we were to give her a force, she would walk in right. So she's kind of always, she doesn't have enough force to walk with any authority. And so she never actually walks in the direction she's pointing. There she goes, right? But again, this is, again, we have a desired direction and we have an actual direction, and we need to counteract the actual one. So this is our desired velocity, right? Let's pick a desired velocity. So the desired velocity, we'll call it V desired, is this. We want to be moving at 3 meters per second. Let's see, what's the actual velocity? Driver.body.velocity. Okay, so oh boy, no, linear velocity. It's important to spell right, kids, and to use the full name of the things. Did I fix it and then we're just still catching up? Yes. So technically, I think if I minimize this real quick, it'll catch up real quick. Yeah. Nope. Error updating systems, no such property, velocity. Yes, let's start over again so that I can clear that. So let's go back, start simulation. See, this is so much quicker than starting up Mythruna, right? Okay, so she's moving along. She's gonna fall into the hole. I gotta get rid of those holes. Oh no, she's trying to walk up the hill. She's gonna fail. She's gonna fall into the hole. Although she didn't fall into the hole before. Oh, there she goes. Alright, so let me get rid of those holes real quick. I put them in there to test to make sure that the underground part of the world was set up correctly. And I can take them out just as easily as I put them in. Like that. Like that right there. Okay, velocity. So we do get a velocity. It's very small. And I need to close a bunch of these. Hold on, let me just close a bunch of these things so that I have a little clearer. We're probably going to want that, actually. Yeah, let's close those. Close all these. Yeah, now we can get a little bit quicker, clearer. Okay, so bing bong bink, bing bong bing. There you go. Bada boom, bada bing. All right. Okay, so no more holes in the ground. She's going to try walking around in circles. She's not doing a very good job. And the way I did this before is update. Yeah, so we kill the vertical rotation. Some point we get the actual velocity by we do our own calculation for actual velocity, because the linear velocity is calculated. So what we want is to put, I'm not going to worry about moving ground at the moment. I know I can deal with that. So we want last position, loci. And so last position, not set, driver body position. And so then we ought to be able to calculate state.actual velocity dot set current body position, subtract the state last position, and then state okay, so then we ought to be able to log the actual velocity, and we can compare that to the linear velocity of the body itself. And I realize there's something I've done wrong here. Okay, so we can see that the velocity is completely incorrect. That is subtract local. We're not actually subtracting. There we go. That's better. Yes, we get teeny tiny values for actual velocity and less teeny tiny values for velocity, because one is calculated based on our existing forces, whereas the other one's reality based on like what we're hitting and so on. So I can get rid of this. It's doing what I expected it to do. And so let's look over at the existing code again. I saved myself some time that way. Okay, so we get the actual velocity. From that, we calculate steering and all that other stuff, which we haven't added yet. And from that, we will get a desired velocity. And that is where the mover comes in, the rigid body mover, which is essentially one of the things that I was smart about when I created the mob drivers, is that they had these pluggable rigid body movers. Now, I didn't actually set up different ones for different characters, but kind of hard-coded it all in here. But anyway, so from here we get a rotational velocity, and so we build a target velocity. Yep, target velocity, and I'm going to go ahead and reinstantiate that. So rotate it forward for the current orientation to get target velocity in world space. Right. Okay, so that was my desired velocity before. And so let's say we want to move at 3 meters per second, which is what I calculated before. We did that. That was our target velocity. You know what, if I... And so... Force mult local 10 times mass. I don't know where that number came from, but that's what it took. But somewhere we're taking the target velocity, subtract local actual velocity. So we calculate this V desired to be 3 meters per second. And then we have def new force equals target V desired, just straight subtract state.actual velocity. Make sure that compiles. Yep. Okay, and then there was some other things I did based on contacts and things that we're gonna ignore for the moment. I just kind of want to see her walk around in a circle where it looks like she's actually walking around in a circle and not drifting around in a little weird way. So we got the force. Some of this is basically zeroing it out if we're not. So we'll set force up equals null, and we'll body add force. Okay. So we'll make sure, for the moment, that there is no upward force. And then we will multiply 10 times our mass, which I happen to know is 50. So we'll just set to 100 at the moment. And then we'll driver.body add force. And I actually don't need this then. So let's see what happens when I do this. Yeah, so see now it looks like she's walking in the direction she's walking. Does everyone understand the difference? Did you follow all that? She's not actually going at the speed we want her to go. If we like we calculated the actual velocity, if we look at so if we log the length of that, that would be speed, would be actual, state dot actual velocity dot length. What I need to do is have a way to put these in the debug HUD so that we can so she's moving super tiny. If we set this up so that she's moving with more force, like 10 times her mass would be 500. Whoa, that's too much. Whee! Did she go right through the wall? Yep, I suspect she went through the wall and under the ground, and she's flying away. Alright, that's why we can do this and restart the simulation. Okay, so now, yeah, so she's moving pretty good. Before she hit the ground, she was moving a lot faster. Okay, so the thing is, the force should counteract, because basically we're saying what direction is she actually going, what direction do we want her to go, and we apply a force to make those match. If she's going way faster than we actually want, we should be applying a negative force, and so I don't know why it didn't sort itself out. Like if we set this to 150, what's it gonna do? So so she's way that's a lot. Like that's a lot different. Yeah, so she's all the way over there now. Like suddenly she's moving faster. Okay, so as soon as she starts to turn, it's when she's going in the direction we already want her to go. So I'm actually glad I have this, because this has been a long-standing problem of mine, is dialing in that force value. It makes no sense to me. Force should equal mass times acceleration. So mass should definitely be involved. But the values seem so arbitrary all the time. And I'm just not sure why. So I need to debug this math, and what I really want is the ability to put any of these values, like I have the heap value up here. I'd like to be able to just put any of these values up here so I can watch them without having to look at the log, because then I can have different sections for different bodies. And so that's probably what I'll add next on my own time. But she's walking in a circle, and you can kind of see what's happening. And if I see, even 110 should be okay. 120. Yeah, friction is mass dependent. Well, it is and it isn't. Like, so her force just accumulates is what's happening. And it's not supposed to be, right? The force is supposed to counteract as soon as her actual velocity gets ahead of her desired velocity. But anyways, there's the sticking friction, which is mass-based. But once you move, your friction, I don't think is mass-based. Once you're actually moving, I'd have to look at the math again. I didn't write it. I only barely understand it. But mass, like, determines whether you're stuck or moving. And then it has a minimal impact, I think. At any rate, she's got friction. She's got 0.7 friction on all these contacts. Which is why if I suddenly cut off her movement, she should slow down and just start. Yeah, well, I mean, that's not fair because it resets every time. So, but anyway, I have a place to play with this now. I may just, if this is an interesting topic for you guys, it certainly drew more than normal. What I will do this week is beef up the tool and make sure, you know, all of my I's are dotted and my T's are crossed. My T's are dotted and my I's are crossed. I'll make sure the tool's up to date, but that we get right back into this, but with like better debugging materials. So if this is an interesting topic, I will continue it next week. I do want to actually put out another minor Mythruna release that has some of that cool annotation, maybe annotations on the hand-drawn filter, because I think it'd be cool if you guys could start collecting some cool pictures and stuff and have like a cool thing to post. But okay, so I think this is where I'm going to end it, mostly because it's after 11 and I have to really use the bathroom. But so she's moving. I may play with it just a little bit to educate myself again on what's what, and then we can continue where we left off next time. So, any last questions before we wrap it up? As always, if you are working on something creative, I hope that your muses are singing loudly and that you have an extra creative time. If you are not already on the Discord, you can join the Discord at that link in the upper left with that cool little dragon password that you got there. That's also where you can download the game, but there's a link to the Discord there too. And I will go ahead and say thanks for watching. If you have any other comments or questions about what the content you just saw or anything in general, please like or please comment on the video. I read all the comments. I'm plenty of free time to read the minimal amount of comments I get on videos, but yeah, I read all the comments, so if you have questions, I will try to answer them. Otherwise, I will see you guys next time. Go forth and be productive. Thanks again, guys.